Limits of indeterminate forms in squeeze theorem. Finding limits of indeterminate forms. An indeterminate form is mostly you'll find 0 over 0. You can also find infinity over infinity, or 0 to the power infinity, or 1 to the power infinity, or something like that. But you'll mostly look at 0 over 0. That's your indeterminate form. And what that means is you gotta go a step further if you want to evaluate your limit. This can't be your final answer. If you cannot evaluate a limit by direct substitution, sometimes we can use algebraic techniques to rewrite the function so that we can evaluate the limit. And there's 3 different ways to rewrite the function. There's factoring, multiplying by the conjugate, and finding the common denominator. This first example is about factoring. If you use direct substitution, like I was using in the previous video, if you substitute 3 for x to evaluate the limit, you get 3 over 3, 3 minus 3 over 3 squared minus 3 minus 6. That comes out to be 0 over 0. This can't be your final answer. What you need to do is you need to simplify the limit. Because we have a quadratic equation here, what we can do is you can factor the quadratic in order to simplify the limit. Let me show you. The limit as x equals 3, x minus 3. If you factor out x squared minus x minus 6, 2 numbers that multiply to get negative 6 and add up to get negative 1, negative 3, and 2. So that's factors to x minus 3 times x plus 2. Notice that you have an x minus 3 on the top and on the bottom. They can cancel out. You're left with the limit as x equals 3 of 1 over x plus 2. Now you can use direct substitution, plugging in 3 for x, and 1 over 3 plus 2, and 1 over 5 as the answer. This next problem is an example of multiplying by the conjugate. You usually find conjugate problems with square roots. So first, you can use direct substitution to evaluate the limit. You get square root of 4 minus 2 over 4 minus 4. Square root of 4 is 2, 2 minus 2 is 0, and 4 minus 4 is 0. You'll get 0 over 0 again. So what you need to do is you need to simplify this. And the way to do this particular equation is to multiply by the conjugate. And what that means is if you multiply this square root of x minus 2 by its conjugate to get something like x minus 4. See how similar these are? The conjugate is when you write the original expression, right, you have square root of x minus 2, and you replace the sign in the middle with the opposite sign. Here we have minus, so you're going to replace it with a plus. This is the conjugate. What you'll do is you'll multiply both sides of the fraction by the conjugate, which is square root of x plus 2 in this situation. Square root of x times square root of x is x. Negative 2 times square root of x plus 2 times square root of x, so those cancel out. And then negative 2 times 2 is minus 4. Leave the bottom as it is, because now you have x minus 4 on the top and on the bottom. Those will cancel out. And you're left with limit as x equals 4 of 1 over square root of x plus 2. All that's left is to substitute 4 for x. You have 1 over square root of 4 plus 2. 1 over 2 plus 2. So 1 over 4 is the answer. This problem here is an example of finding the common denominator. Usually find like fractions like this, that's how you'll know to use the common denominator. First step when you're evaluating limits is always to use direct substitution. You get 1 minus 4 over 1 minus 4 over 4 minus 4. You get 0 over 0 again. That means we'll need to simplify it. You're finding the common denominator. What you do is you have your fraction here, let's say 1 over x. Look at the denominator of the other fraction, which is 4. You're going to multiply both sides by 4 now. The other fraction is 1 over 4. The denominator of the other fraction is x, so I multiply both sides by x. What that comes out to is 4 times 1, which is 4, over 4 times x, which is 4x, minus 1 times x, which is x, and 4 times x, which is 4x, all over x minus 4. Now that we have a common denominator here, this 4x and this 4x are the same, we can combine this fraction. So you get 4x over 4 minus x, because 4 minus x here, over 4x, all over x minus 4. You see that this 4 minus x and this x minus 4 look really similar. They're sort of like opposites of each other. That's because they are. If you factor out negative 1 from 4 minus x, you get negative, so negative x divided by negative 1 is just x. 4 divided by negative 1 is negative 4. Notice how now you have x minus 4 are the same. You have one on the denominator, and one on your denominator here. They can cancel out. It'll leave you with negative 1 over 4x. So if you have opposites here, they will cancel out to negative 1. Just a handful of shortcuts to remember. So the limit as x approaches 4 of negative 1 over 4x. You can substitute 4 for x here. So you get 1 over 4 times 4. I get negative 1 over 16 as the answer. These next two functions are going to be sort of special. You'll need to memorize them. The limit as x approaches 0 of sine x over x is 1. You can say it right there. That's something you'll need to memorize, because if you just plug in 0, you'll get 0 over 0. So if you have sine x over x, limit as x approaches 0 of sine x over x, that's automatically 1. You just need to memorize that. This other one is 1 minus cosine x over x. As x approaches 0. You can see the value there is 0. That's another one you'll need to memorize, along with the sine x one. The one with the cosine x is equal to 0, and the one with the sine x is equal to 1. Very important to memorize. Some practice problems. There's sine of 2x over 2x as x approaches 0. Notice how in sine x over x, this x on the top and this x on the bottom are the same value. So as long as they're the same value, this limit holds true and it equals 1. This 2x here and this 2x here are the same value. So you can evaluate it as if you're evaluating this, because they're essentially the same thing. That's 1. Now you have sine of 2x over 3x. What we want to do is we want to get this 3x and this 2x to be the same thing. But since this 2x is inside the sign, you don't want to do anything to it. It's going to be way too complicated. But this is free. You can So you make the denominator like the numerator. 3x, you want it to turn to 2x. The first step is to take this 3 and move it out. So you get 1/3, because the 3 is the denominator, so 1/3 times the limit as x approaches 0, sine of 2x over x. Still not done yet, because we want this x and this 2x to be the same. What to do to get this x into 2x, you multiply it by 2. Since you're multiplying the x by 2, you also multiply the top by 2 as well. So you get 2 sine 2x over 2x. You see we multiplied by 2 here. You can take this 2 now and move it outside. So you get 2 times 1/3, which is 2/3, times the limit as x approaches 0 of sine 2x over 2x. Now you have the same value here, which means this limit can be replaced by 1. 2/3 times 1 is 2/3. That's the answer. You have the limit as x approaches 0, 4x plus sine 3x over x. Because we have this plus in the numerator, the first step we're going to do is we're going to expand the fractions into 4x over x plus limit as x approaches 0 of sine 3x over x. Let's deal with this first part. You have an x on the top and an x on the bottom. They'll cancel out. Now you're just left with 4. And if you have the limit of any number, then you can just take out the limit. So the limit as x approaches 0 of 4 is just 4. Now let's do it this right side. You want to make this x, turn it into 3x. To do that, multiply both sides of the function by 3. So you get 3 sine 3x over 3x. And take this 3, move it outside the limit. So you get 4 plus 3 as x approaches 0 sine 3x over 3x. Now you can see that 3x and 3x are the same. That means this limit is equal to 1 now. 3 times 1 is 3, plus 4, that's 7. Now you have the limit as x approaches 0, sine 2x minus cosine x plus 1 over x. The first thing I'm going to do is rearrange this limit. I'm just switching around the cosine x and the 1 here. So now this looks familiar. You have 1 minus cosine x over x. And you can split this fraction up now. So you have sine 2x over x plus, as x approaches 0, 1 minus cosine x over x. This limit here, it's already simplified enough. This limit here is equal to 0 if you memorize it. Because 1 minus limit as x approaches 0 of 1 minus cosine x over x is just 0. Let's make this x turn into 2x. Multiply both sides by 2. Yet limit as x approaches 0 of 2 sine 2x over 2x plus 0. So 0 is this, so plus 0. Move this 2 on the outside. You get 2 times the limit as x approaches 0 sine 2x over 2x. These are the same now. You can replace this limit with 1. That's 2 times 1. The answer is 2. Here's another one. Limit as x approaches 0 of cosine x times tangent of x over 2x. This one's actually really easy. So remember that cosine x, remember that tangent of x is sine x over cosine x. That's all over 2x. Now even cosine x on the top and a cosine x on the bottom, they'll cancel out. You're left with limit as x approaches 0 of sine x over 2x. You want to take the 2x and turn to x. So you can do is you take this 2 and move it down the outside. That's 1/2 times the limit as x approaches 0 sine x over x. You can take this limit, replace it with 1 now. 1/2 times 1. The answer is 1/2. Now this last part, the squeeze theorem. If f of x is between g of x and h of x for all x, this is just a bunch of gibberish in an open interval containing a c except possibly c itself. And if limit as x approaches c of g of x is equal to L, some random number L, and limit as x approaches c of h of x is also equal to L, these L's are the same thing, then the limit as x approaches c of f of x is equal to L. Let me show you how to solve one of these. If negative x squared plus 2 is less than or equal to f of x is less than or equal to x squared plus 2, for all x, find the limit as x approaches 0 of f of x. Notice that doesn't give you what f of x is, it just says between negative x squared plus 2 and x squared plus 2. The first step when you're having a squeeze theorem problem, you take this limit as x approaches 0, in this case 0, so you can put limit as x approaches 0. You're going to take the limit of the left function and the right function. You can just use direct substitution to get negative 0 squared plus 2. That comes out to 2. Do the same limit, but with the right equation instead. That's x squared plus 2. Substitute 0 for x, you get 0 squared plus 2. And that's also equal to 2. Now since the limit on the left and the right are the same, they're equal to 2. The limit as x approaches 0 if f of x has to be equal to 2. Here's a graphical explanation. So this is the problem we just did. This top line here is x squared plus 2. This bottom line here is negative x squared plus 2. And f of x exists in this red shaded area. Notice that f of x is squeezed between negative x squared plus 2 and x squared plus 2 at x equals 0. Notice that the value here is 2. The y value is 2. And that's why the limit as x approaches 0 of f of x is equal to 2, because the other two functions squeeze it into this little spot right here.